This conference will now be recorded.
Okay, yesterday we were looking into the login transaction and we observed the behavior of the your heap, right? What we observed is while I'm doing multiple iterations of login, the memory, the heap was going up, and then when the GC got executed automatically, or when I triggered the GC manually, the heap came down completely to the original point. Right? So the pattern is kind of, it goes up and comes down, goes up and comes down. When it comes down completely to the original state, which means whatever objects that are created, whatever the heap occupied by those objects got reclaimed. Right? Your initial memory is equal to the final memory after doing multiple iterations of your login. Okay, so which means we can definitely be assured that for a login there is no memory leak, and even when we are going to do a load testing later involving login, you will not have a problem because of a login. That is what we are trying to do, right? As part of the early performance engineering, we will try to take each and every transaction and then try to analyze this, so that when we go and do this combined workload load testing, you will not face the out of memory error or your memory leaks. Right? Still, there can be out of memory error because of the load. Right? When the heap memory is only 2 GB of heap and you're going to execute for 500,000 users, because of the capacity, you might still get out of memory error. That's a different case. But there should not be any out of memory error because of the your memory leak. That is what we're trying to understand or analyze it in the as part of the early performance. Okay, so now let me go and deploy another war file. I think it is already there. Just go and start it. I'll start the server, and we will now look into the second transaction, the view librarian. Okay, so whatever we did yesterday for the login transaction, we will repeat the same thing for your view librarian as well. Let the server start. Did it start or it ended? Let me start it again. Socket. Let me go and check it in the logs. Somewhere it is not getting started. This is at 8:55. Let me see any other Java process running in my machine. Just give me 1 second. There's something running. Let me try one more time. If not, I'll go and change the port. I think some port issue is it is coming. Let me do it one more time. Okay, I think there's some bind issue. What I'll do is I'll try to go and change the port server.xml. Let's showing the same error. Just give me 1 second.
Satish, your screen isn't sharing.
Yeah, I'm just trying to just uh, kill some services. I'll start it again. Only 1 minute. I'll make my mobile user as a present organizer. Okay, and I'll quick. I just started the laptop. Just give me 1 minute. It is coming up. I don't know what happened to my web apps folder war file. Somehow it is missing. I don't know what is going on. Anyway, now let me try this. It should work. Yeah, it should work. Let me go and get my J profiler as well. J profiler. Yeah. Okay. Okay, it is attached to a running JVM. Evaluate instrumentation. Okay. Okay, got it. Fine. So what we'll do is now the login is there. Okay. We will do multiple iterations of view librarian. Okay. So I'll just click this view librarian. Okay. I will duplicate this page. Okay. Okay. And then probably I'll keep doing this view librarian multiple times. Okay, and we'll try to understand the pattern. Okay, so now the memory is at 130 MB. Okay, let me do a couple of more view librarians. Okay, it is increasing. It is now at 160. Let me do a couple of more. Okay, now it is at 188. So it started at 90, it went to 200, right? 200, 210. Okay, now it is at 230 MB. Okay, what I will do is for us to understand the way the committed size is going to increase, and after when it is going to reach somewhat for 480 or 470, right? It will try to get more memory from your RAM because maximum where we can go is up to 838. Okay, either I can do multiple iterations on my own, or let me quickly open my Jmeter so that I can easily go and run this for the multiple iteration so that my memory will increase easily. Okay, open my script library.jmx. I'll just run it for with one user. That should be more than enough. It's 8084. 8084, and then in the third group, I'll just say one user should be more than enough. Save it, and then let me run it. Okay, so we'll see now the memory is at 234. Okay, so when multiple iterations are going to get executed, you will see the memory is increasing to 247, 250, 263. At some point of time, you might see a GC will happen. Okay, whenever it is going to cross 50 percentage, maybe, right, you will see a GC will happen. So far, GC hasn't got triggered at all. It is at now 284. Maybe once it crosses 300, you can expect a GC. 306, 307. So far, GC has not been triggered by JVM. 320, 336, not it. 350, 353. Definitely before. Now, if you see it came down to 130. It started at 90, right? It went to 365. Now it came down to 132. Right? Yes, there is a GC. Okay. Again, it will keep on increasing. Okay. Maybe I'll try to put, instead of one user, I'll try to put 2 or 3, so that this happens little fast. I cannot wait for this much of time. So let me go and just put it as a 3 users, so that the increase will be a little bit fast. So now let's see. For now, when it came down, it came to 138. Okay, in fact 121. Okay, now let's see. Now again the memory will increase. Again after some time the GC will happen, and let's see how far it is coming down. Okay, so now we should see memory again going up after some time while the test starts. Yeah, it started increasing. 232. So we'll keep an eye on this low point, right? When the GC happened, it came down to 121. Okay, so let's see. I think there's again a GC happened. So it came down to 150, right? Initially it came down to 121, then it came down to 150. What we need to notice is memory will go up. When GC happens, it should come down completely. Okay, so if you see here, when GC happened, it came to 151, right? Now it came down to 181. Correct. So whenever GC happens, memory comes down, but does it comes down completely? No, right? 158. Now it is second GC at 181. Let's see next time when it goes up. Let's see how far it goes up and how far it comes down. Let's monitor. Now again the GC happened. It is 207. So if you see here, if you look into all the low point, right? If you look into all the low points, there's a gradual increase in heap from 150 to 180 and then to 207, right? So this curve or this kind of memory pattern, if you just let it go, right, what will happen? Every time memory is going to go up, it is going to come down, go up, come down, but it is not coming down completely. Again, if you see here, it is 227, 227, 212, 180. So every time it comes down, you could see that it is not coming down completely. Okay, what I will do is I'll stop this, and then maybe I'll run it for say 7 uses, so that memory will be much more faster. The growth is much more faster, so that we can cross this limit, right? We can cross this 500 MB limit, and also probably see whether the app is going to get crashed. Okay, so now you should see memory going up little fast. So far the committed size is only 500 MB, right? So far JVM didn't go and get additional memory from your RAM. It is still at 500 only. Okay, now again memory came down. GC happened, it came down to 280. Okay, earlier it is 227, it is now 280. Okay, again it goes up. Now if you see, there is an increase in your committed size from 512 MB. The committed size increased to 526. So JVM, looking into the memory growth, it requested for more memory from your RAM. It got some more memory. Okay, as you see, as this gap narrows down, you will see much more committed size getting increased, because there's a cushion. Max memory is 838, right? So if you see again, there is an increase. It now the committed size increased to 563. Okay, but if you see all the pattern,
Satish,
right, this curve, right?
yeah, I have a question. I
Mhm.
mean, automatically, because we given max heap size is 830, right? 800 above, right? So automatically it will take up to 800, or else
Correct.
it will beyond, it will
No.
increase.
JVM will automatically take the additional memory if it is required.
Okay.
Yeah. See
Now this
now
is
I
only
didn't do
happening,
anything.
right?
Yeah, I didn't do anything, right? Now if it went to 700, the computer size went up to 700. So as your
Oh,
use size increases, as you use more heap, your JVM will go and claim more memory from your RAM. But it cannot go beyond 838, because that's the max you're given.
okay,
So
fine.
if you see the brown line at the top, says that the max available is 838. Okay, so yeah,
Okay.
let's go. Will the test continue, so that we'll see what happens. And also the way it works is, if there is no load, okay, after some time it will also give back that memory back to the RAM. Okay, your committed size will see, assume that there is no leak and you stop the test. What will happen? The GC will get executed and your entire memory will come down. So the additional memory that is now given will be given back to your native. So your computer size will decrease. Okay, that's how automatically it will get more memory from your native, and it will also give back that memory back to your RAM if there's no load. Okay, now if you see, almost your computer size is equal to your max size. Okay, so your use size is also now narrowing down. It's almost going up, right? So overall curve, if you see, it goes up. The GC happens, and the memory also comes down. It doesn't, does not it's not coming down. It is coming down, but it is not coming to the original. Every time it comes, goes up and comes down, it doesn't come to the original portion. So there is a leak, you can suspect for sure. And if you let this happen continue, right, maybe after, depending upon the leak, depending upon the max memory, it might crash after 1 hour or 2 hour or 3 hour. Say you have a 4 GB, for example, right? If you have a 4 GB, it might not crash immediately, but if you run this long running test, that's why we run a long running test, endurance test, right? In a typical 1 hour load test, you will not see crashes, you will not see out of memory error. But when you run it for 8 hours, 12 hours, 20 hours, there you will be able to look into the pattern very clearly, and at some point of time you can also go on the JVM might get crashed because of the out of memory problem. Okay, so if you see now it is almost 678, 684. Let me also do some more view library so that I can do it little fast. We'll just wait for a minute to see if we can go and get this out of memory error. Yeah, it is almost there. Now it is at 807 MB. Almost your used memory is equal to your committed size. Okay, GC update came down, but again it will increase. Let me do a couple of more. Why I'm not getting data, in fact. So it takes too many connections. Okay. Okay. Let's hope you might get this. Let's see. There's another problem because of which data is not coming. It says that the database, there are too many connections to database. We will look into that issue, that too many database connections, right? We will look into it tomorrow. There's a reason for that. Okay, if you see in the log, yeah, now if you see, I think we got the, did we get an exception? No. Yeah, we're getting this too many connections, right? I'll explain you why there's too many connections tomorrow. Okay, but today we are looking for the memory problem. Let's see whether we get this memory problem. It is almost there. Any point of time now you might get a out of memory. Okay, because it's very narrow. Nothing is there. In couple of seconds you should see it out of memory error. I think the Tomcat is not even responding. I don't see any messages coming. Let's see, but it should throw out of memory error because nothing is there. Free size is only 1.93 MB. Free size is there. By now, yeah. Now if you see, there is a java.lang. Out of memory error exception. Okay, so now there is, and it's a warning that exception that is thrown by the JVM, saying that memory is not available, right? And eventually your Tomcat will also get crashed. Okay, so while we do this early performance, right, we will not go till this end because we have seen the pattern initially itself for 10 iterations, 20 iterations, right? We have seen the pattern. Memory goes up, comes down, but it's not coming to the original position. Okay, so by doing the 20-25 iteration itself, we know that there is a leak. We will not need to run for 30 minutes, 1 hour to go till the out of memory error. That is not required while you do the early performance engineering. You look into the pattern. If you suspect that memory is not coming down, then we have to go further for the analysis. The reason I showed you is for two purposes. For one is for you to understand how this committed size and max is going to work, and second is for if the leak is going to be not addressed, what will happen. right? That is why we run a long running hours. Okay, what I'll do is now I'll just go and kill this. Okay, I'll go and kill this. Okay, this will get detached anyway. Yeah, now let me go and
How to
start
kill
the
this?
server again.
No, how to
No, I
kill? I
just
mean, just
closed
we
the
need to know.
Tomcat.
Okay.
See, in the Linux, you will have a command. You'll have a kill command where you can go and kill it. If your Tomcat is running as a service, right? Then you can go to the services, and then in the Tomcat service, there will be it will list the Tomcat service. You can go and right click it, and then you can go and stop it. Right here, I'm running it in the command line, so I was just closing it directly. But ideally in the Linux, right? Linux machine, you get the process ID of your JVM, okay, and then you will give that kill and then provide the process ID. That process will get killed. Okay, so when you do a this by yourself, right? So you obviously can do all this stuff if you have this server administration tool. You can get that access to that UI. Normally, the infrastructure team will have it. Okay, say for example, if it is an cloud mission, if it is an AWS, right? In the AWS console, you can go and start, stop, restart everything. You can do it. Or if it is a Linux mission, you can go to the Linux mission, log into that, and then find out what is the process ID of that particular application, and then use the kill command to kill it. Here for your learning in your laptop, since it's a Windows laptop and I'm running it as a in the command line, I just close that window for killing it.
Okay.
I'll
Okay,
start
sir.
it again.
Yes.
Yeah. Oops. I stopped it running. So if you see here, this is how I can go and do. Let me kill it and come back again because I wanted to start it clean for my analysis. Okay, for my J profile analysis, I wanted to start clean. So I don't want any test to get executed. I'll close the Jmeter as well. This is enough for me. Now I know that there's a problem with the view librarian. I will go for the next level of analysis using J profile. That's it. Okay. So okay, fine. Now I have attached it. What I'll do is now I'm not going to look into the pattern, right? I know the pattern is going to be bad anyway. Okay, I'll go to the something called live memory. Okay, and in the live memory, I'll go to the recorded objects, and then I will start recording it. Okay, before start recording, let me log into this. Okay, yeah. Now I will do okay. Now I'll start doing the recording. Okay, and then I'll go into a view librarian. Okay, so while I'm doing the view librarian, okay, these are the objects that got loaded into the your memory. Okay, and you start looking into the top 5. Probably there are multiple things that is going to get loaded, right? So while we do, we'll go and do 3, 4, 5 iteration, and then just take a look into the top 3 or top 5. You can probably take a snapshot also so that you can do a comparison. Otherwise, just observe. First observe. Don't need to worry about it if you couldn't able to remember, right? There's a byte, java.lang.string, hash map, java.lang.node, right? So I'll just go and do it in one more iteration and then see what happens. Okay, what is getting? You also look into the size and the instance count also. Okay, you have 7000 KB of byte, 567 KB of Java string, 480, right? Just keep looking, just observe it. Okay, we're not going to infer anything. Just observe it. Now again, if you see in the top 3, top 5, still the byte is there, Java double is there, string is there, key is there, right? Top 5, it remains the same. Okay, again, let me do a couple of more view librarian. Okay, and then keep noting it down, right? Java.lang double came to the top, 1440 byte 7500, hash map 1288, right? Now what I'll do is just I'll do a GC and then see visually, just see what went out and what is there. It is 1400 KB, 7500 KB, 1388 KB. Okay, I'll run a GC. Okay, if you see, pretty much everything gone except for this, right? There were a couple of KBs, right? There were a lot of hash map iterator, hash map node. They were in KBs. While after executing the GC, everything went got deleted. Only this Java.lang double is there in the top still. Okay, let's go and do a couple of more iterations. Okay, again the key hash map key iterator came, hash map node came, byte came, Java.lang double is still there. 682 KB is there for your hash map key iterator and 50,000 bytes for hash map node. Okay, let's do some more. Just observe what is there in top 3, top 5, and see whether it is going, whether it is going out or not. Because these are the live objects, live recording of the objects, right? So now let's go and oops, I sorted this. Okay, it's there. Okay, now what I'll do is I'll go and run a GC again. Let's see what happened to the key iterator, what happened to the hash map node, what happened to the byte. Let's see what happens. Okay, the hash map iterator went out, hash map node is still there, and java.lang double is still there. Okay, let me do one more GC. Pretty much I could see these two are not going away. Okay, this two is still there. Okay, so assuming that these two things are maybe a culprit. Okay, let's try to go and see what is this object. Okay, right click this. Okay, and then say show allocation tree for this selection. Okay, so allocation tree is nothing but the object which got recorded here. You wanted to understand what is this object, where is this object getting created. Okay, that's why I right clicked and then went to the allocation tree for selection. Here if you see here, it's the same tree hierarchy what we saw in the response time analysis, right? What it says is the java.lambda double is getting created in your own package com.java.t.servlet library mem.populate list. So as I was saying, the convention is package name dot class name dot method name. com.java.t.servlet is a package name. In that library mem is a class file. Populate list is your method, and this is getting called from this method, and this is getting called from this class and this method, and this started from the view librarian. This is the hierarchy. This is your flow, right? The structure of the classes that are called when you hit the view librarian. This is called, and from there this is called, from there this is called, from there this is called, right? So this is one of the culprit because of which this java.lambda double is not going away. Even after running GC, this object is not going away. This object is created in this method. So when you go and share this details to your developer, what you're going to say is there is a java.lambda double object created in your package in this class file and this method, which is not getting deleted even after running a GC. Take a look why it is not getting deleted. That is what you're going to say. We will not go to the code and then go and see what is happening. That's not our. If we can still do it again, when if you're going to be more experienced, 5-year, 6-year experience, and into that same project for multiple years, then you can also get access to the code, and you can also go and look into it. That's not mandatory, but if you have the code, yes, you can go and look into it. But from a roles and responsibility, you need to analyze this and share at least up to this point. Right now, there is something called allocation hotspot as well. Hotspot is something similar in the response time also, right? We have seen this hotspots. So it will list down the object directly, and then here it is top to bottom. Here it is bottom to top. That's it. There are multiple hotspots. You will see multiple objects getting listed here. For example, let me go here. Let me go back to this and then find out this one. Okay, because this hashmap node also it is not going. Even running a GC, this 265 KB is still there. Okay, let me try to understand where it is getting originated. I'll go and say show allocation tree for selection. Okay, here where is this view librarian? This hash map, right? It is getting somewhere. It is getting invoked in the prepare statement in the DB connection in this librarian dev.view in this view librarian. So it is again our own package only, but this particular object, the hash map, whatever that is showing there, that belongs to java.sql.connection, which is an external package, right? We created this is a JDBC connection. The for doing a database connection, we would have downloaded the MySQL connector, which is an external package. Okay, so that's why it shows us com.java.t.point.davo.db connection. That is our package. And if we go further, it is all java.sql.connection. So which means developer might say that this hash map object is not something created directly from our package. Rather, it is coming from the this external package. So they might not be able to fix that directly. They might have to probably upgrade that external jar. Right. So two things we are suspecting. One is the java.lambda double, and second is the hash map node. This is very clear. This is something coming from our own package, our own class files. But this one, when we look into the call tree, it is pointing out to java.sql connection dot prepare statement, which is something native of your Java SQL library, okay, the external library. Okay, so this is how you will see. You no need to go and look into all the 20, 30 that is appearing. Okay, just keep looking into the top 5 and then see whether it is getting removed when you run a GC. Run multiple iteration. Just keep a note. It's not that easy. You need to probably spend 30 minutes, 1 hour closing it, watching it very closely. Okay. Once you know that, yes, obviously when you do a multiple iterations, right? 10, 15, the leak object will come to the top automatically because it is not going out, right? So the number of instance count and the size will keep on increasing. So maybe initially it won't be evident, but after you're doing 10, 15, 20 iteration, definitely the object is getting leaked. If it is not going away after GC, it will come to the top 1 or 2, 3, it will come because there's no way, right? It is not escaping, it is not deleting. So even in the first iteration, if this might be in the top, down in the 10 or down to 20, but when you do multiple iterations, it will come to the top. And then you go and look into the allocation call tree for this object and find out what is the reason, and then share that reasons to your developer. Okay, any question guys so far?
So this will occur while running the endurance test, right? So that generally endurance will go longer hours. So then only we can observe these leaks, object leaks or memory
No,
leaks.
no, 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 no. See, for the endurance, it is a little different. Okay, let me open this. Whatever you're doing it is only for the single user performance. We are doing a live recording. Okay. So the way we are analyzing it, we're doing a live recording of the object for a single user analysis, early performance, right? But when you go for a load test or endurance test, you're going to have load, right? You're going to have 200, 5,000 user load. That time we cannot use JPEG recording. It will be too much. Okay, it is not recommended. You cannot do a live profiling or live recording of objects while you do a load test. For that, what we'll do is, while we are running an endurance test, we'll observe the pattern, and when you think that the pattern is bad, then we'll go and take a heap dump. Okay, heap dump is like dumping all the objects that are currently there in the heap at this moment. Okay, and it will have a lot more information about when the GC ran, and then what are the old objects, what are the new objects. A lot of information is going to be there in the heap dump. That heap dump, we will analyze it. So while doing an endurance test, if the memory pattern is bad, we will not use JProfiler for live analysis or live recording. Rather, we will go and take a heap dump. Whatever we are seeing now, that is for your single user profiling, early performance analysis, where we just going to do one user, two user, multiple iteration, and then do the live recording, and then observe the objects. So both are objectives are maybe to understand the issue or memory, but approach is different.
Okay, understood. So another
Okay,
question.
so yeah,
So this J
yeah, we
profile
will look into that.
is paid version, right? So what is the open source version of J profile? What is the
Um,
you know
See, for
the other tool?
profiling, I don't see any open source available to my knowledge. Okay, uh, and though it is commercial, it is not very costly. I think it is $200 per year. So if you go and ask your project to sponsor $200 per year, they would be pretty much happy to do it. I haven't seen any open source profiling equivalent to JProfile. There might be something, but it is not that good comprehensive like JProfiler. You have a thing called YoKit, again a commercial profiler. Yeah, at least I have not used any good open source profiler that will do a job similar to JProfiler. I can check it out if there is any GitHub project available. Let me check and come back to you. But yeah, it is a commercial, and you need to pay $200 license fee for using it. But for your learning, for your POCs, before even purchasing it, right? Like the way we are doing it, you can install the trial.
Okay.
Yeah, I'll stop it here. We will continue tomorrow. What we'll see tomorrow is there is one more option called heap worker. Um, Another way of analyzing the same problem using the heap worker option in the profiler. Okay, and then we will look into a couple of concepts of the shallow heap and retain heap, and then incoming reference and outgoing reference, and then we will look into the heap dump as well. So that's a plan for tomorrow and day after.
Okay.
Okay. Yeah, fine. Guys. We'll meet tomorrow then. Yeah, thank you guys.